Every day, millions of us walk into the kitchen, turn a knob, and hear that familiar click, 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 whoosh. A ring of fire bursts to life. But have you ever stopped to actually look at that flame? It's not the bright, dancing yellow of a campfire. It's a sharp, almost artificial-looking, glowing blue. Fire's supposed to be yellow and orange, right? At least that's how we usually imagine it. We've drawn it that way since childhood. So, why does your kitchen stove break the rules? The answer involves a frustrated 19th century chemist, some clever engineering, and the exact same physics that gives stars their colors. Welcome to Everyday Objects, Extraordinary Stories. Let's find out why your stove is blue. To understand the blue flame, we first need to understand the yellow one. In a candle or campfire, parts of the flame don't get enough oxygen to burn completely. This creates tiny, unburned particles of carbon, which we call soot. As the fire heats up, these tiny soot particles glow bright yellow and orange. Those hot soot particles glow because of a phenomenon in physics called blackbody radiation. It's the exact same reason an old-school light bulb glows. But your gas stove is different. It runs on a hydrocarbon gas, usually methane or propane, and it is engineered to achieve something called complete combustion. When this gas mixes with plenty of oxygen, it burns so efficiently that it produces little to no soot. No soot means no glowing yellow particles. Instead, the flame's hot, excited molecules and tiny reactive fragments emit light of their own. Much of that light falls in the blue part of the spectrum, giving the flame its characteristic color. But how did we tame this cleaner, soot-free fire for our kitchens? For that, we travel back to a German laboratory in the year 1855. Chemist Robert Bunsen had a problem. The gas flames of his time were yellow, flickery, and incredibly smoky. They covered his glass beakers in thick black soot and simply weren't hot enough for his experiments. Bunsen realized the flame wasn't mixing with enough air before it burnt, so he and a university mechanic named Peter de Saga designed a clever new burner. They added tiny adjustable slits at the base of a metal tube. This allowed air to rush in and mix with the gas before it reached the top to be ignited. The result, a cleaner, soot-free, intensely hot blue flame.
The same principle behind the Bunsen burner, pre-mixing gas with air before ignition, became the blueprint for the burners in modern gas stoves. Underneath the burners on your stove today, air and gas are mixed, using the same basic principle Bunsen helped popularize over a century ago. That blue glow is the ultimate sign of efficiency. It usually means you're burning the fuel more efficiently and getting more of its energy as useful heat. And it helps keep your pots and pans clean. In fact, this color is a built-in safety feature. If you ever turn on your stove and see a lazy, flickering yellow or orange flame, it can mean the burners are clogged, dirty, or not getting enough air, which can produce dangerous carbon monoxide. That steady blue glow is generally a good sign that your burner is operating as intended. So, the next time you boil water for pasta or make a morning cup of tea, take a second to appreciate that little blue ring. You aren't just looking at fire, you're looking at a remarkably efficient chemical reaction in a 170-year-old piece of scientific history right in your kitchen. And here's what I want to know. Have you ever wondered why your stove flame is blue? Did you ever notice the difference between a blue flame and a yellow one? Drop it in the comments, because I have a feeling most people have never actually stopped to think about the color of fire in their own kitchen. If this changed how you see something you use every single day, hit like and subscribe to Everyday Objects, Extraordinary Stories, for more stories about the hidden engineering and history hiding in everyday objects around us.